a small presentation on energy audit instruments. Energy audit, as you all know, is a systematic method of collecting data, as the term is audit. So you understand that we are collecting the data, compiling it, and using the data for suggesting certain energy conservation measures to an industry or to a residence. So we need to collect the data, which starts with measurement. Energy audit instruments are the tools for collecting this data. In this presentation, you will get an overview of the energy audit instruments used in thermal audit. This is not a detailed presentation. We'll discuss this in more detail by physically looking at those instruments when we are offline. And we would be actually understanding how to use those and practically. But the objective here is to give you an overview of those instruments used in thermal audit. By thermal audit, I mean the audit which involves the energy conservation, especially in thermal systems. We would be discussing the uses of these instruments along with the overview. So the first instrument which I have in mind is a combustion analyzer. Combustion analyzer is a widely used instrument for auditing of the thermal systems, especially where the fossil fuels are used. Now, what is this combustion analyzer? Just have a look at this. You see, this is a very compact, involved instrument. We are not going into what exactly are the sensors used and how is the instrument actually programmed and how the results are obtained. That is not the objective here. The objective is to simply give you an overview of what exactly this combustion analyzer does, what things are being measured, why are we measuring those things, and how it is useful in the energy audit. So, as I said, combustion analyzer, as the name indicates, it is used for analyzing the boilers or furnaces wherever there is a combustion phenomenon. So what is done is that uh, we insert the probe. You look at this. There is a probe over here. This probe is inserted in the combustion gases. I mean the flue gases. Means the products of combustion. So you insert the probe in the flue gases, and you get to know many things. So what are the things we are interested in? With the combustion analyzer, we are interested in knowing the oxygen content in the products of combustion. The combustion analyzer will tell you how much is the oxygen present in the products of combustion. Now, why is the oxygen present in the product of combustion? Oxygen, as you all know, is used for the combustion phenomena, and not all of the oxygen is utilized in combustion. So some of the oxygen will come in the flue gases, and the oxygen which is present in the flue gases will give you a fairly good idea about how much air is being supplied for combustion phenomena. If the air supplied is more, you get more oxygen. If it is less, you get less oxygen. So how to use that data in the calculations that we'll see later. But an oxygen measurement in the flue gases is an important parameter which gives you an idea about the phenomena of combustion. Whether the combustion is with the excess air or whether the combustion is with incomplete air-to-fuel ratio. Similarly, the combustion analyzer will, with its inbuilt probes, the sensors, will tell you how much is the carbon monoxide and how much is the carbon dioxide. It is also programmed. One method is if we use this parameters, that is oxygen which is present in the flue gases, the carbon monoxide which is present in the flue gases, the carbon dioxide which is present in the flue gases, and do our calculations, the combustion chemistry, and come out with the results. The other is, and it is generally that in all the combustion analyzers which are available in the market, it has an inbuilt program to do the calculations. Now, what it does is it can calculate many things. The most important thing it does is it calculates the efficiency of the combustion system. It calculates the efficiency of the boiler or the furnace which you're talking about. Now, what is the logic of the calculations that we'll see when you do a detailed discussion on the energy audit of boilers. So this is one provision. It tells you about the draft which is present. It tells you about the pressure, and it gives you the matrix about the flue gases. Okay, it gives you the constituents of the flue gases. So this is a very handy tool, and it is indispensable in fact, because without this you cannot comment on whether the combustion phenomena which is happening is proper or not. And because we cannot measure that, and if we are not able to comment on that, we won't be able to tune the boiler. Tuning means what? Tuning and testing means tuning means you need to control the air to fuel ratio in the boilers or in the furnaces so as to optimize that. Okay. So this is a very handy tool. I'll just give you one or two photographs so that you understand how it physically looks. So this is one photograph I had already shown. You can do a Google search and you can find out which are the major manufacturers. We have one instrument in our college, which the combustion analyzers in the market. Okay, it's pretty costly. This is one testomec. We have a testomec instrument. You look at the screen and it gives you an idea about what exactly it gives you. Okay, so it tells you about the flue gases, there's a pressure probe, the carbon monoxide, the smoke number, the differential pressure, all these things you get it from the on the screen. Okay, and you see that there is a provision of connecting this to the computer ultimately, downloading this data, and using its inbuilt program, you can generate reports. Okay. So it's pretty easy job for an energy auditor if you have a combustion analyzer to make a comment on the energy efficiency of the boiler system. The other instrument, which is in not using the expensive probes as in the combustion analyzer, but it uses bit of chemistry, okay, similar to what we had learned in our school days, that we can use different chemicals for absorbing different gases, provided those gases have an affinity towards those chemicals. So this is what is the principle of it. So generally, this fire which is an instrument, it can measure the oxygen content and carbon dioxide. Now, why to measure oxygen and carbon dioxide? As I already told you, that by measuring the oxygen and carbon dioxide, you get to know, get to comment on the phenomena of combustion in the boiler system, in the furnaces, right? Uh, so this instrument can also be used as a substitute because this would be obviously a cheaper instrument, and if you don't want to use a costlier combustion analyzer, one can also comment and do the calculations on the boiler system by using this Pyrite instrument. What is the principle I told you? That it contains the chemicals, okay, and it would those chemicals would absorb the gases, okay, and you can just turn it upside down, okay, and by using this, you can take in the gases, flue gases sample, and you can measure them by using the volumetric method. You can measure and you can tell how much is the oxygen and how much is the carbon dioxide. Okay. So this gives a reading which is more accurate, and it is very simple, and it is not costly. The problem with the combustion analyzers is that this combustion analyzers, not only the initial cost is high, but its calibration is also very costly. And you can imagine that if somehow, because you are experiencing very high temperatures, and if it is not handled carefully, the running cost or the operating cost of the combustion analyzer is also too high. There are other instruments. We in the analysis of boilers are interested in knowing the temperature of the flue gases, or we are interested in knowing what is the temperature of the steam. We are interested in knowing what is the temperature of the water. Okay, so all these temperatures, which are useful in calculating the energy balance of the boiler or energy balance of the furnace, for that matter, the temperature becomes critical, and we can use contact thermometer has like this, which has a thermocouple and which can be contacted because it has a probe which can be inserted into the stream. So if there is a stream of flue gases or if there is a stream of hot air, if there is a stream of hot water, you can simply insert that probe into that and you can read that temperature on the indicator. Okay, so this is a very handy kind of thing. Imagine that you have a thermometer instead. So you need to go closer to the thermometer, watch them, and then take the reading. So that is not required when you are talking about this contact type of thermometer of this type. It has a digital indicator. So this instrument is used. However, this instrument or this thermometer has a problem that if the locations are not easily accessible, if the locations are not easily accessible, in that case we cannot use these thermometers. Or if the locations are a bit risky to reach, then also it is not desirable to go for this kind of thermometers. So instead, there are some instruments now which are contactless. These thermometers, they are contactless, working on the infrared principle, wherein you can easily capture the temperature. So what you have to do is that just um, look at this figure. It's like a gun. Okay, it's called as gun. So infrared gun you use, and you just put a laser uh, or the radiation you have to uh, impine on the surface whose temperature you need to measure. Okay, and then you can get the temperature easily on this dial. Okay, so what is the advantage? The advantage is that if you are, for example, if there is an oven, okay, or if there is a furnace of the boiler, there you cannot just reach there and get the temperature, right? So instead, you can simply use this gun and you can get the temperature by um, throwing the radiation at that spot. Okay, this is very handy not only in the thermal audit, okay, but it's also useful when you're diagnosing the electrical circuit for hot spots. Okay, if there is a short circuit and because of the short circuit, a particular wire gets hot. Okay, so that also you can spot out by using this thermometer. So it's also useful in the safety audit, right? Or even in firefighting situations. Um, and obviously, as I told you, that it has wide applications in the thermal audit, and it's used widely because it is very convenient to use. Obviously, its initial cost is higher than the contact type of thermometers. A more advanced instrument which would not only capture a particular temperature but the whole temperature profile of the surface, whole temperature distribution of the surface is the infrared camera. So it is like a camera where you get, look at this camera, okay, this is a flip camera, flip my camera, and you see that on this camera you have captured an image, okay, wherein uh, this this image would show you the different temperatures of not a single spot, but of the entire surface which is being captured by this camera. So this is an extremely useful instrument in the audit, and again, obviously, it has an advantage over all the other two types of thermometers because this is a thermometer which simply gives you one temperature at one time, and this is you need to have a contact, physical contact over of that surface. But this you would simply get a photograph. You take a photograph of a particular surface, you can imagine that, and you get the entire image. I'll show you one or two images here. For example, I'll use this camera. Look at this physical system, and look at this image which has been captured by the thermal camera. Okay, and look at these temperatures which you get over here. Okay, so you get an idea about the temperatures, and this is a color code which tells you the temperature range. Okay, similarly, this is what I had captured by using the thermal camera. Look at this. So you can make out the different colors and you can know the temperature. So you can know where exactly is the higher temperature or lower temperature. Okay. So this gives you, for example, if there is, suppose this is a chill line, okay, and you find that at a particular place there is, and this is, let us say this is insulated, and this is insulated, okay, and let us say that there is some leakage, okay, some leakage of chilled water. So what will happen that when you are using this camera to capture this image, that spot will be clearly shown as a low temperature spot. Okay, and then you can make out, right? When you can make out the temperature distribution, and you are expecting a uniform temperature distribution because that particular component is insulated, and when you are finding an abrupt small temperature over there, small spots over that, then you can identify the problem, and then you can take corrective actions. So this is a very useful tool for doing an energy audit. This kind of reports you can generate, which is called a thermography. Okay, so by using this camera, you generate a report, the thermography report, and you can make a presentation to the company for which you are doing the thermography, uh, and tell your suggestions. That, for example, look at this. I had done a thermography for this, and I had located a hotspot here, and this is an electrical switchboard. From this, I had suggested that this is a place where there is some short circuit, and because of this, these wires are getting excessively heated, and you need to take corrective measures. Okay, so this kind of suggestions are possible. It is not. It won't be possible to you physically go and open that board. Opening obviously is required, but uh, take those spots by your open eyes. Okay, that would be more difficult. Instead of that, and also that is not an evidence, but if you capture it, if you capture that by using a camera and make a presentation to the authorities, they would take corrective measures in identifying this kind of stuff. Okay, so it is used not only in the thermal audit, but it is also used in a safety audit. This kind of thermal camera. This is an ultrasonic leak detector. You see that this ultrasonic leak detector is used in the compressed systems, compressed air systems. You will find that in industry, uh, uh, much of the electricity is used for compressing the air and using it for pneumatic tools. Now, because you are using electricity to compress it, uh, the energy which is required is a highly energy intensive process. Compressing the air, using it for the electric pneumatic tools is a very energy intensive process. And you will always find the industry which is using compressor complaining that their energy bill is high. So in that case, if they are complaining that the energy bill is high, a good way is to look at the or do an audit of the compressed air systems. So there are a number of ways of doing audit of compressed air systems, and we'll be covering that in a few lectures of ours. But we need to have proper instruments to do the audit. So one of the instruments which is used in the compressed air system audit is ultrasonic leak detector. What it does is that it simply identifies the leak of the compressed air by using the ultrasonic principle. So if you are able to identify the leak, then it goes in very handy for quantifying what is the leakage, how much is the leakage, and how much is the electricity which is being wasted because of the leakage. Okay, how to do those calculations this later. But this kind of instrument which can detect it, okay, the and especially if the pipes, the compressed air pipes are not accessible, in that case, such kind of instruments are useful. Otherwise, we can use a simple method of which is called soap test for identifying the leakage. This also is one of the instruments for doing the audit of compressed air systems, in which you measure the flow rate of the compressed air. And this is a simple principle. You use an orifice. Orifice would give you the flow rate by measuring the speed, and you know that flow rate is nothing but a product of cross-sectional area into velocity. So if you get the speed by using, you look at this, there's a probe, and there is also a fan. It's not very clearly seen, but you have uh, you have some fan which can be held in the stream, air stream, and this stream uh, uh, would rotate that fan, And if the fan is rotated, you would get to know what is the speed of the air, and that speed into the cross section area would give you the flow rate. So this is a very handy kind of thing which is often used in the industry. Okay, so all these instruments which I have discussed now, okay, they are useful in doing the energy audit. We would be actually using those instruments when you do the class kind of stuff. But for this time being, I feel that you have got a good overview of the instruments which are used, especially for the thermal audit, and you also have understood how exactly these instruments are useful in conducting an audit. Okay, so I would suggest that you do some Google search, find out what are the companies which provide those instruments, what are the typical costs of those instruments, and that would also give you a commercial understanding, okay, a market understanding of these instruments, and make your learning more fun. Thank you.